Inside the steel factory, how wire rods are made from iron or mining. Full process. Intro. From earth to engineering. Beneath layers of rock and soil lies the foundation of the modern world. Iron ore, raw, unshaped, and ancient. What follows is a journey of transformation. A journey through fire, force, and precision. This is the full story of how iron ore becomes steel wire rods inside a modern steel factory. Chapter 1. Iron ore mining. The process begins at vast iron ore mines. Depending on the deposit, mining is done through open-pit mining, where massive excavators remove surface rock. Underground mining, where tunnels reach deep ore bodies. Drilling rigs bore into solid stone. Controlled explosions break the rock apart. Giant excavators load the ore into haul trucks capable of carrying hundreds of tons. The raw ore begins its journey to the processing plant. Chapter 2. Crushing and screening. Freshly mined ore arrives in large, uneven chunks. Inside the plant, jaw crushers break the rocks into smaller pieces. Cone and impact crushers reduce them further. Vibrating screens separate the ore by size. Oversized pieces are crushed again until uniform. The goal is simple: prepare the ore for refinement. Chapter 3. Grinding and beneficiation. The crushed ore is ground into a fine powder using ball mills, rod mills. At this stage, iron is still mixed with waste minerals. To separate them, magnetic separators attract iron particles. Flotation tanks remove unwanted materials. Iron content rises dramatically, from around 30% to more than 65%. This purified material is known as iron concentrate. Chapter 4. Pelletizing or sintering. Fine iron concentrate cannot be used directly in furnaces. It is reshaped into iron pellets, small, hard spheres, or sinter, fused porous lumps. These forms allow air to flow easily during smelting, improving efficiency and heat transfer. Chapter 5. Blast furnace. Making molten iron. The blast furnace is the heart of steelmaking. Layers of iron pellets or sinter, coke, a carbon fuel, limestone, are charged from the top. From below, superheated air is blasted in at over 1,200 degrees Celsius. Inside, temperatures exceed 2,000 degrees Celsius. Chemical reactions strip oxygen from the iron ore. Molten iron forms and flows to the bottom like liquid fire. Impurities combine with limestone to create slag, which floats above the iron. The result is hot metal, also called pig iron. Chapter 6. Steelmaking, BOF or EAF. Molten iron still contains too much carbon. It is transferred to basic oxygen furnace, BOF, or electric arc furnace, AF. Pure oxygen is blown into the molten metal at extreme speed. Excess carbon and impurities burn away. Alloying elements may be added to achieve specific properties. Now the metal becomes clean molten steel. Chapter 7. Continuous casting. Molten steel is poured into water-cooled copper molds. As it cools, it solidifies into long square bars called billets. These billets are cut to precise lengths, slowly cooled to prevent cracks, inspected for internal and surface quality. They are the building blocks of wire rods. Chapter 8. Reheating the billets. Before shaping, billets must be reheated. They enter reheating furnaces at temperatures between 1,100 and 1,250 degrees Celsius. The steel becomes soft and malleable, ready for deformation. Chapter 9. Wire rod rolling mill. This is where transformation accelerates. The red-hot billet passes through a series of high-speed rolling stands. Each stand reduces thickness and increases length. The steel moves faster and faster, sometimes exceeding 100 kilometers per hour. Gradually, the square billet becomes a smooth, round wire rod with precise diameter. Chapter 10. Controlled cooling. Freshly rolled wire rods are extremely hot. They pass through controlled cooling systems that improve strength, control microstructure, prevent internal stress. Cooling is carefully timed to achieve the required mechanical properties. Chapter 11. Coiling and Packaging. The finished wire rod is guided into large coils. Each coil can weigh 1 to 2 tons. Coils are tied securely, labeled by grade and size, prepared for transport. Chapter 12. Quality Inspection. Before leaving the factory, every batch is tested. Tensile strength, diameter accuracy, surface finish, chemical composition. Only steel that meets strict standards is approved. Final uses of wire rods. Steel wire rods are essential for electrical wiring, construction reinforcement, nails, screws and bolts, springs and cables, automotive components. Conclusion: the power of steel. From deep underground rock to precision-engineered steel. Inside the steel factory, heat, science, and human skill come together to shape the backbone of modern civilization. This is how wire rods are made. This is the full journey from iron ore to steel.